Hi everyone. Evelyn Darcy is my name. I'm here to talk to you about site surveys, which is a continuation from last week's lecture where we talked about formulating a brief and how to do so. Um, Gathering your site survey information along with brief are the first starting points for a project, whereby you can take that information to go forward and to start forming a feasibility study for your project. This morning we will look at different types of surveys and different information included. We'll look at topographical information, which is the height above sea level. We will look at dimensional surveys. We will talk about services surveys. We'll touch on hazardous material surveys, structural surveys. We will look at access and limitations to carrying out site surveys. So our first flow diagram, which you saw last week in the beginning when the client has touched base with you and begun preliminary inquiries regarding a project. Just as a reminder that you as an architect and the client are each considering each other's competence, commitments and complications to take on this project before making an agreement to visit the site. So from that point, we have here your architect's appointment, whereby the client has agreed that you are the right person for the job, and you've also made your commitments to take on this job for that client. So from that point, we've got various items that need to be considered in commencing a project. So on the flow diagram here, we have confirming the brief, which is what we talked about last week. We have advising on consultants. So here you might advise that you might need an engineer or specialist designers or quantity surveyors to assist you on the project. You will advise on consents required, so this means whether the project will need planning permission, whether it will have to go through the building control amendment regulation system, fire safety certificates, disability access certificates, and so on. So that's the legislative information that you're going to have to compile. You will draft a program. So between you, you will find out whether your client wants this project to be built in a year, 2 years, 3 years, 6 months, whatever. But it's important to find that out, I suppose, for your own point of view, to factor into your office practices workload and to know what to expect. Then you will enclose terms. So these are terms for payment and terms for times for payments. And you will advise on appointing a surveyor. So a surveyor will have specialist surveyors who can carry out complex site surveys. On smaller projects, the architect is usually the surveyor of the site or the existing building. From that point, then you will arrange a site inspection. So this point here is what we are going to consider in this talk today. Okay, so various points on analysing and preparing survey information. For the site analysis, we will take some notes on inspections. We'll look at the site cover, so that's the ground surfaces, what sort of heights, light angles are positioned on the site. We'll also maybe do some desk research on future developments that might be happening within the site or in the vicinity of the site. So from that you'll prepare site survey drawings, and then from this point you'll put all that information together to analyse the survey versus the brief and continue then on for consultants' advice if required. So what is the purpose of a site survey? The purpose of a site survey or property survey is to obtain information on the site, the existing buildings and surrounding buildings on the site, if there are any, to assist in the development of the design and to ensure it is feasible in terms of dimensions, client and statutory requirements. Okay, so this is the point of the site survey versus the brief. So you need to ensure that the project proposal is feasible, whether it fits on the site, being a very simple one, and whether it's possible in terms of is it likely that you will be able to get planning for the project. I have some slides from the projects that I talked to you last week about, just to show you the different types of survey that might be involved within these projects. So, for example, the Houston South Water project up the top here is a very large scheme of apartments over commercial space within an even more enormous site. So the scale of the survey required here would be quite different to, for example, say the school canteen, which is one room. I'm looking for different kind of information on a survey here. So, for example, I look at where the existing water is coming in, the heating system, the drainage, and so on. Perhaps all sorts of scales of information on the site survey for Houston South Water, and obviously this was not carried out by my practice, it was carried out by specialist surveyor. The project on the corner down here then is the youth hostel in Knockree, which is in an area of outstanding beauty in Wicklow. So the topographical information was really important here. You can see there's quite a steep slope on the site. We needed to find out about the existing trees, arboricultural information, and then from that point you can begin to design a site-specific building. So the responsibility for a site survey is with the project architect or a designated person with suitable qualification, for example, a chartered surveyor. So there are people who specialise in carrying out surveys. We will hear from one of them later on this morning. It's important to get a brief from the client, or write a brief for yourself on exactly what dimensions are required. Even more so if you're going to designate the survey information, the survey job to somebody else. They need to know what you need. Cross-check your limitations on professional indemnity. Surveys must be carried out by an RIAI member or a person with minimum 5 years experience in surveying. And before visiting, there's desktop work that you should do to get as much relevant available data as you can about the site before you visit. So obviously the correct postal and physical address of the property or site, the definition of the site property, the ordnance survey map, which will show you some outlines of boundaries. You will also need to do some research on planning restrictions, the local authority development plan, if there are national monuments, protected structures in the area, what is in the curtilage, so that is in the surrounding context of the immediate site, are there any protected trees, and so on. You'll need to be sure about your client information. For example, does the client actually own the site? Which can cause legal issues if this isn't clear, who actually owns the site that you wish to design a building for. You will, if you can, gather any existing plans or previous drawings of the site or a building on the site. You will look at what the location of the utilities are, so where is the electricity, phone lines, gas, water, drainage, and so on. And any information you can find as to whether any archaeological remains are on the site, or if the site is near any known area of archaeological interest. Some other factors to consider when you are carrying out your desktop study. Okay, so this is prior to or immediately after visiting for the first time, probably before you even start measuring out. So this is taken from a Tipperary County Council document on rural villages. The factors that are listed here are what is the planning history, what developments have previously been permitted or refused on the site, what is the natural heritage of the site, so what is the proximity to Natura 2000 designated sites. So these can be looked up online. You need to consider the built and cultural heritage. Is the site or building close to a protected structure? is it close to national or recorded archaeological monuments? Are there any natural special features of placemaking? For example, if you're in the west of Ireland, for example, the old stone walls that surround fields, there would be a feature of placemaking. That's part of Irish cultural heritage. The infrastructure then carrying to and from the site, so any existing water services, roads and access, or flooding risk. So this is an ordnance survey map, which I am sure you're familiar with from previous projects in your course. It's a good starting point. They're quite clear and basic. It would show you general layout. They will show you boundaries as assessed. They will show you existing buildings and access and so on. So this site is in the centre of town in Naas on the main street. This site at the centre here was a project that I worked on, which was a supermarket renovation project. Okay, so here you can see the planning stage drawing with the red outline that shows the boundary of the site. And this yellow access line here is showing a right-of-way along a laneway. So the main entrance is to the front here, but there's a right-of-way, which is a right of use of this access route by the site here, while it is not within the site boundary outline. Some information that you can take from these survey, ordnance survey maps is the eastings and northings, so locating it on the planet. You can see the center point coordinates are taken here. We can see the scale of this map is at 1 to 1000. And we have the survey information at the top here. So this was first, this version of the map was surveyed in 1988, revised in 2016, and the levels were placed down in 1987. So it's quite a long time ago. Some levels here at the centre, which are our guidance point for you for your project. I mentioned archaeological areas of interest earlier. So here you can see a sort of strange shape on the map, which is a clue that this is a motte, which is an ancient mound with a structure in the centre of it here. So given the proximity of this motte, this archaeological area of interest, we had to take account of that in the design for the building that we were placing on the site in here. When you zoom in, there is some more information to be found on this. So 0.72 gives you a plot area for this site here, which is adjacent to ours. These letters here signify services. So MH is a manhole. We have a fire hydrant up here. We have a lighting pole here. So it's quite basic, but it's a good starting point to show you what, for example, where the drainage might be running along the street, for example, here. The 91.6 at the centre here is the level, so that's the height above sea level. So OS maps are a useful starting point for gathering information for your site survey. And Google Earth is also probably more so. The detail is really quite accurate, particularly if you're in a town area or in Dublin, just to show you the lay of the land, so to speak. So when you're visiting, take all the required safety equipment, personal protective equipment, gear. If you're surveying a deserted site, take another staff member, if at all possible. And usually you'll need 2 people to carry out a survey if you are taking a dimensional survey anyway. But there's also, from a safety point of view, surveying a site alone carries a risk, particularly if it's involving derelict or very old buildings or soft ground, for example, or if there's any other risks associated with being out there on your own. So take another staff member. If not, take your phone with you and inform the practice of your expected time of return, just to maintain, just to be safe. When you arrive, before measuring anything, walk the site a number of times, take a sketch of the layout, and take running dimensions with a diagonal check measurements where you can, where a site might not be, perfectly square, which is rare. The diagonal check measurements will help you draw it up when you get back to the office. Take height measurements of critical elements, so height measurements of any existing trees, height measurements of existing buildings, any height measurements you can take, particularly of buildings adjacent to the site. And take a photographic record, including those adjacent buildings. When you're going for planning permission, you need to show elevations and the heights of the buildings adjacent to your site. I'd recommend taking the photographic record either at the beginning or at the very end, just to kind of clear your mind, clear your space for drawing the site up and taking your measurements. Take some notes of the following. What is the date and the time of your visit? The orientation and the access to the site entrance, the level of traffic that are in the vicinity of the site or can access the site. So that's the orientation of the site, north, south, where the sun is coming from. Take note of adjacent buildings which may pose obligations with regards to easements, and that is rights of light, air, rights of way, rights of support, party walls and boundary conditions, are solar design strategies. So if there is a building that is going to be overshadowing your building, or if there's a risk that your new building will overshadow another. Take a note of the area that the site is located in. Is it Victorian, commercial, residential, so on. And take a note of any local adjacent power lines which can need to be taken account of, particularly with heavy goods, vehicles and machinery entering the site, that we don't run the risk of hitting these on the way in or out. The environmental information to be recorded. So assess the potential to create a microclimate which enhances the energy performance of the building and optimizes the potential for incorporating passive and active strategies into the design, including the orientation of the site. What is the access or obstruction to light, to solar radiations? Where is the prevailing wind? Where is the site sheltered? What obstacles are there to access for daylight? What existing trees are on the site? Are they evergreen or deciduous? So an evergreen tree will provide shading all of the year, obviously by the nature of the tree. The deciduous will be bare in winter, so that could help or hinder positioning of the building on site. Are there any existing water courses? What is the topography? What is the slope of the site? Where is the water and waste disposal potential? Are there any potential renewable energy sources that would probably be related to wind or to solar? Are there any nice or interesting views into or out of the site that you might wish to focus your building on? Or what any other unusual features or aspects that you can see? This is an example site analysis sketch from that same document from Tipperary County Council. So it's a semi-rural site, it's a rural village. So you can see here how the architect is beginning to overlay information onto a sketch plan to map what is on the site, but also map information that will be useful for the future design. So you can see here that we have the site boundary in red, excuse me. Sorry. We have shown that, the architect has shown here where the sun travels in the summer and where the sun travels in the winter. You can see there's quite a difference in the angles here for the sunlight. She has shown the topography. She's shown where the land is sloping. This is quite a steeply sloping site. You've got 20, 19, 18. Each of these is a difference of a metre. We can see what the existing boundary conditions are. There's a mature hedgerow to one side. There are some shrubs and trees, and there's also one notable tree here that she's taken account of. We have the existing entrance here, and we have also an indication here, these green lines, where there's a view to the mountains. So documenting everything down onto one plan, you can begin in your mind to have some clues and ideas for how you might design a building to go on the site. Also, sorry, just here some indications of the buildings that are next door, adjacent to the site, and where the wind is blowing across the site. Some further considerations. Consider the requirement for an environmental impact assessment. So these are essential on all very large sites. Consider the requirement for a more detailed or professional survey. Know your limitations. Consider requirement for heritage, conservation, arboricultural advice. So arboricultural is relating to the trees and natural trees, shrubs, boundaries on site. Consider the requirement for radon testing. There is a map. If you look this up, you can see across Ireland has radon naturally leaking up through the ground. Some parts of the country more severely than others. So there is publicly available information on this. You can look at the map of Ireland to find out if your site is in a high radon area. And then on return to the practice, the survey is drawn up and recorded by the person who conducted the survey in a perfect world. So sometimes I might draw a survey that my colleague undertook. It's tricky. There's usually some questions. You generally end up having to go back and check yourself in any case. So it's better that the person who visited draws the survey. Risk management. Evaluate the risk of litigation compared to the fee. So yeah, so there can be some problems with carrying out a site survey if further down the line there's an issue with the building. For example, if the boundary was wrong, or if there was some element that was undiscovered at the time of the survey, you're leaving yourself open to litigation, to a risk of getting in trouble later on. So to manage this, use the standard RIAI checklists. If you're using specialist surveyors, check that they are insured. Write a disclaimer for unseen or hidden possible defects. So what this means is the survey was carried out by you as a visual survey. No opening up was carried out. So, for example, you are not required to open up walls or to open up foundations or the ground to check condition of anything that can't be seen. Legal maps versus client advised boundaries. So we come across a lot of issues with boundaries in particular, where the client tells you that the boundary line is in one place, and the neighbour has a different idea that the boundary is 500 metres to the north. So this can cause issues also. So check the legal maps. Check with the client boundary is, if necessary. Look at the boundary with the neighbour and with legal advice. Always note the possible health and safety risks of carrying out a site survey. More on risk management, check whether access roads are suitable for construction. Are they wide enough? Are there any restricted heights? Are there any services? check whether adjacent sites are active or if they could pose issues. For example, the site in Naas was beside a school, so there were child protection issues that we needed to be aware of. Aside from that, then, if the site is close to a sensitive area with regards to noise while constructing the building, that can also cause problems. Check if there's any existing habitat on the site. If there's any protected species, for example, bats and types of geese, for example, which could limit or totally prevent you from being able to build on the site if there's a protected species that lives there. Check for previous uses of the site resulting in contamination or any issues with flooding or poor soil quality. So it's an engineering issue if the soil isn't good enough to build foundations in. Okay, I wanted to show you a few slides now of a survey that we got carried out professionally by Murphy's Surveys. This is an existing building, and I will show you some of the keys, some of the information that's recorded on these surveys. So here's a close-up view, and have part of the key here at the side. So we have the floor level, which is this triangle point here. We have the ceiling height, and we have false ceiling height. So there's a ceiling tile in this room. So it tells you how tall the space is. We have door heights here marked. This door is 2.03 to the head of the door. Each of the rooms is named. And then, for example, there's no access to parts of it, so the surveyor will note that also. And also note the elements of structure and so on. Okay, that is this area here in this building in the corner. Now you can see the site survey, which is where things get quite complex. This is a survey of all the existing services to this site. By services, I mean gas, water, drainage, and so on. Just zooming in there on the very front, this is the street. You can see it's quite crazy. How many different pipes, cables, and so on are going both underneath your feet on the footpath and above your head on poles. All the different types are listed in the key here. So just to come back to the urban place map, the OS map, this section here is where we started with our basic information on manholes and lighting standards. Oh, sorry. Whereas in the previous slide you can see the level of detail that the professional Murphy survey goes to. It's quite a big difference. Okay, so at this point here we are. We have carried out our survey. We've taken all the information together. We've prepared our drawings, and then we can compare. So we carry out an analysis of survey drawings versus the brief to see if it's feasible. Those two things will come together, and then you'll finally start to consider form on the design of the building. So here we have a preliminary site strategy study. This is a site analysis versus the brief. So here the architect is beginning to place, this is for a small housing scheme, beginning to place houses onto the site in an arrangement that best suits the topography and the other features of the site. And here we've taken the view into account, where the buildings are orientated towards the view. Looking at how the wind will affect the buildings, looking at the adjacency to existing buildings and how they might relate to this. We have a question here about flood risk, which would be something for the architect to consider, perhaps getting specialist advice on. So in assessing a site's potential, I have a few slides here taken from the Cork Rural Design Guide. So it's obviously in a rural context, but the principles are the same. So we have an existing rural site, which is on the corner of a farm and a civil business, a higher point on the site and a lower sheltered area to the right here. The site slopes, has trees, it's sheltered from the hillside, has hedgerows to the front, and we are going to look now at how a person might think about placing a building, in this case a home, on this site while using the site to its best potential. So I suppose we can learn from our mistakes in the past. It's a typical response. It's a really common house type across Ireland. It's the bungalow from the 70s and 80s, where the house is placed on the highest point of the site. The house is isolated from the landscape with a very manicured, perfect garden and a path, concrete path. We have a type of hedgerow that's been used that is not native, which is not sympathetic to the landscape. So it's not very private, given that you're up on the top of the site. It's common enough where I think perhaps many of us grew up, but we can certainly learn that there are better ways to place a house on a site. The 90s and 2000s, I would say, approach is where it's showing off. The bigger the better. The house is very dominant on the landscape. There's no link with the landscape at all. Again, large expanses of lawn. We've got type of construction with which is not sympathetic to the landscape. Whereas what we would hope people are beginning in the latter part of 2010s to this point is that the ideal place would be to respond to the site itself, to take all the environmental information you have gathered and to place the building in a more sympathetic, happier location on the site. So you'll choose a sheltered area of the site, orientate the house to maximize solar and daylight gain, set the house into the landscape and linked into it. And the massing of the house is then broken down to fit within the context. So all of this information that we have looked at already, so this is all of the information here that we would look at to create or to consider where best to place the house. So I'm just using a house as an example. It is scalable up to larger building types. Okay, so previously we've been looking at rural sites. I wanted to show you a few slides from a site I'm currently looking at a proposal for, which is in Pembroke Street, just off Bagot Street in the city centre of Dublin. So it's Bagot Street at the top there, and Pembroke coming down here, and we've got Fitzwilliam Square just off the corner of the slide here. And this is the site here outlined in red. In considering the site, I looked carefully at the history of the site, how it had come about for a planning application or for any kind of research on a site in this central location. It's important to look at the conservation element of it. The site itself is in a conservation area. So on this map here, you can see Ropes map. This is one of the oldest maps showing how Stephen's Green used to be in the middle of the edge of the city, with the countryside behind it, which is quite amazing to think about it now. See, Stephen's Green is there. We have the castle here, sorry, it's the customs house there, and all the way out there to Bagot Falls Bridge is a little village, Irish town again. There's a tiny little seaside village. I looked at the different maps from that point. So you see here, 1797, the streets have been laid out, but this is still countryside. So only 4 houses had been built on Fitzwilliam Square at that point, and nothing then between Bagot Street and Fitzwilliam Square. Pembroke Street doesn't have a name yet at this point. Some of the scales are quite blurry when you blow them up. This map is from 1844, but you can make out the development happening along Pembroke Street here. It's quite fragmented, whereas Fitzwilliam Square, Fitzwilliam Square is further down off this, but you can see how Bagot Street is much more heavily built up, probably similar to how it is today. These really, really beautiful maps, which are from 1847. Really incredible detail here as to the garden layouts, the paths, and the types of planting that were in these garden spaces, which is just, I think it's very beautiful. These maps also have dimensions on them. They're also beginning to show sewer lines and the services. Again, there is the site that I am working on at the moment, which used to have a public water pump on it. And then I carried out a quick exercise to show the outline of the buildings as they currently are now. This is the Bank of Ireland on the corner, Ulster Bank on the corner of Bagot Street. And then these buildings here, the red outline, are what is on the site today. 1889 map. Again, it's more detail as to the actual shape of the building, how each little building fits on the sites. So it's fascinating to think about the cartographers drawing these up with none of the technology that we have today to map these things. And they are quite accurate when you overlay with today's maps. So as part of this site survey research, I looked at all of the old maps. I also looked at Tome's directory, which will show you what was in each, what commercial enterprise or who lived in each building along the street. This map is taken, or extract of the map is taken from the Dublin City Development Plan. So you can get some information as to what the permissible or existing uses on the site are. This red line across here means it's in a conservation area. The green just cut off at the corner there is Fitzwilliam Square Conservation Area. Each of the red asterisks shows a protected structure. The yellow colour is conservation, and the purple in this instance is for commercial uses. So part of your desktop study will give you an idea of what is likely to be permitted on the site that you're looking at. Google Earth can give you lots of information also. So here I'm just as part of my desktop study, I have showed the boundary, the extent of the site to the front. I have a clue now as to what the boundary looks like as it's shared with the building adjacent. And my red asterisks here are showing which are the protected structures on the streets. And another wider angle then that's showing the subject site in context.
Hello, my name is Roisin Nicole, and I'm really sorry that we can't. Hello, my name is Roisin Nicole, and I'm really sorry that we can't all be together in person this year. I'm particularly sorry that I've had to pre-record this session due to my health not being great at the moment.
Which is a colleague.
My talk is about wobbly buildings and digital surveying.
Who is going to talk about
my background here is a photograph of me last year on my way to Clayfest in Wales. We stopped off in the beautiful landscape. I have a background in architecture, and I'm now working as in building surveying.
Thanks very much.
I work for Murphy Surveys, recently rebranded as Murphy Geospatial. So we send vans and surveyors and tripods and equipment like total stations and 3D laser scanners around the UK and Ireland and further afield. In this presentation, I will cover what is a wobbly building, my definition of that for the purposes of this survey, what is digital measurement. Then I will show a 3D walkthrough of the interior of a historic building and a condition survey that I did using that same 3D virtual walkthrough software. And I will show a point cloud survey, which is an example of a barn I received from Sarah Roberts with thanks. And just to finish up, the limitations of digital surveying and my belief in the benefits of sketching. In the context of this presentation, what is a wobbly building? When I told my uncle, he said it was a building that moves. And that's not quite what I intended when I set out to talk about these. My definition is the kind of buildings we're familiar with as, as clayfesters, maybe buildings built from earth, built from hand, that don't completely have straight lines, that have curves and alcoves and are a bit wobbly, or older buildings such as this one where the timber is sagging or the building doesn't have a straight vertical line. They're a little bit wobbly. So with this wobbly building, and I'm calling this a wobbly building maybe because it's from earth, because the windows are at various heights, they're not straight. Would this wobbly earth building benefit from digital surveying? And I think this would be a good example of a building that would benefit from a digital measured survey, because of window heights, window shapes. Yeah, it's a little bit quirky. I think this would be tough to survey by hand. So digital measuring equipment would typically be this total station with based on trigonometry and 3 points and the little computer doing all the calculations. So placing a tripod with a prism, this prism here, above a nail or a control point, a known point, possibly capturing that known point also with a GPS location device, and then recording points in the logger by noting that the laser is pointing, or the viewfinder is pointing at maybe the top of a tree, or a window corners, 4 window corners, or edge of path, whatever is being recorded and tagged and logged to be measured. And these reflector targets can be placed on the elevations of buildings, again as a known point or as a control point. And for those buildings that are wobbling in my uncle's definition, as in moving, to carry out the survey again at a later date using those same control points would show that the measurement of the building has varied since the previous measurement, and would show that movement has occurred. This is an example of a measured survey that was carried out of a very small cottage. I think it's really useful to be able to capture the thickness of walls, the walls that are not at right angles, the walls that you might assume are running straight, but actually it stops short of the line of the walls in the adjoining rooms. Similar here. It can capture ceiling heights, floor to ceiling, sill heights, door heights. There's a lot of information captured here and presented. The Matterport camera is a 3D camera. This is it down here, this black box with 9 separate cameras, 3 facing upwards, 3 facing downwards, and 3 going straight across. It sits on a tripod and spins 360 degrees, and each scan or spin is recorded on an iPad. Then that gets uploaded to the Matterport cloud. It gets processed and spit back out as the walkthrough model. So this is a project that we did for the Royal Hospital Kilmainham in Dublin, Ireland, and they are hosting our a 3D walkthrough on their website. So it's a digital record of the interior space. So it's possible to pan around to take a look at the detail of the building, to move between spaces. And this can be used as an archival record. However, it's hosted, this particular one is using the Matterport software and hardware, and it's hosted on the Matterport server. So we can't download this digital walkthrough. We have to maintain a subscription with Matterport in order for us and for the Royal Hospital to be able to see it. There's a dollhouse view where we can rotate or look around it. And then there's a floor plan where we can see the full extent of the room surveyed, and we can hop into a particular space if that's what we want to see. It's useful for, I think, short term, possibly while a design is underway, while you maintain the subscription with the server, and that you can have a record of details that you mightn't have picked up during the site survey, for example, where sockets are located, are there fire extinguishers, are there light fittings, doors, a count of things. It can be useful back in the office to maintain a record of that. This is another Matterport survey which I carried out using the 3D camera. It's a very derelict building. The clients were a public sector body, and obviously not many of them visit the building. So it was useful for people sitting at their desks in offices to be able to see the condition of the building without having to go there. I mean, it's actually environmentally quite an unsafe building. Many dead pigeons, fouling all around. So just to show you in the floor plan, I was able to label the rooms with different names to cross-reference room A, room B, main hall, to cross-reference with the condition report which I wrote up. But I was also able to note the condition onto the image. So for example, this one, I noted damp penetration, dampness on the wall dividing room A from the main hall due to defective box guttering at roof level. And this 3D walkthrough isn't showing that box guttering, it's only an internal view, but because I carried out the overall survey from the outside, I'm confident in making that comment. So, bricked up doorway. So just comments for the client to smashed windows to better be able to understand the building as they're walking through this 3D walkthrough. Bird fouling and damp staining, dampness due to defects in roof and skylines. The timber floor in the gym was, bird fouling, was quite damaged and dangerous to walk on in places. The two that I've shown are both ground floor, but it is possible to do multi-story surveys using this Matterport camera, and it does show them so that they sit on top of one another. And then there is the option to take measurements. So for example, it's approximately 18 foot from floor to ceiling. Next, I'm going to talk about point cloud 3D laser capture. And when I was preparing for this talk, I mentioned this to Sarah Roberts. And I'm very grateful for her just sending me this example of a project that she worked on. So I've never seen this building in person, but here's a photograph. It's a barn. Sarah sent me some DWG files, which typically people use AutoCAD to use. I'm actually using LineSight, so I was pleased to see that it could open in LineSight. So it enables, I don't know actually if there's a control network in this used for this scan, or if it's in a local grid or a national grid. In Murphy's, we usually, in Ireland anyway, we use the ITM coordinate grid system. And I'm not familiar enough with LineSight to know where those, well, there's a grid reference down there maybe, sorry, I don't know. So this is the massing of the buildings on the site, the barn and the adjoining buildings, the spaces between them. We can also view this 3D model in wireframe and see the insides, see through them. So a laser scan is similar to the total station measurement, except instead of taking one point, the tripod spins around and takes all the points, pings off any surface that it can see, and then all those points, that the cloud of points has to be processed in an office. So sometimes if a string of points are noticeably in a plane, or if a plane of points are noticeably in a plane, it will generate that wall, or it will generate the truss, the timber. So some of it is artificial intelligence, and then some of it needs a human eye or a human processor. The point cloud information can then be exported into drawings that we'd be familiar enough with on CAD. For example, a floor plan. And this is the kind of thing that I think has really usefully been picked up by the laser scan, that these walls are not straight. There's 3 or 4 kinks in that particular wall, and also that it's not parallel to this one. Also that this wall, I think if I had surveyed this in person on site, this wall probably would have been straight, whereas again there's a kink to it there. They're not. This building is not completely straight compared to this one, continuous compared to this one. Also, this is not a right angle. The spaces between these buildings, and it's quite a large building, of course, too. The survey will also, the surveyor will or the processor from the survey might add additional information in text format, such as door height is 0.85 meters, or floor to ceiling height 1.27 seems a little low, but possibly, and sill height is 0.55. So just to be aware of those little codes and the extra information it's providing. This is the roof plan that's been generated from the point cloud data, and we can see all these rafters that are missing or that are misshapen. Great detail. And in close up, these timber joists and the not straight walls. I don't know what scale this survey was scanned at, but it is important that that you don't design to a scale different to the scale at which the survey, I mean, if you survey at a scale of 1:100, if the survey is carried out at a scale of 1:100, you shouldn't be designing 1:50 based on that survey information. But it is okay if the survey is carried out at a scale of 1:20, 1:50. It is okay to design at 1:200 or 1:500 based on that. So you can design, I can't remember the words, greater or lesser scale. You can, your survey detail must be captured at a small scale. I think that's the word. So 1:20 or 1:50, 1:100, and be careful that that's appropriate to the scale at which you intend to design from the data that has been captured. That's quite a technical point, but I'm sure it'll make sense to one or two people at least. In section, this section drawing just captures all of the rafters and roof timbers just overlaid on top of one another, being piled on top of one another. Whereas so I think it's interesting that we can see the different angles at which they were constructed. If you would like to check out some other forms of digital surveying that Murphy Geospatial have carried out, our projects page has some really interesting case studies in it. You can filter them by different services. And this is an interesting one I found, subsurface investigation, a ground penetrating radar that was carried out on a chimney flue in London. So I leave that to yourselves to discover if you're interested. I don't want to give the impression that digital surveying can replace sketching a building and surveying a building by hand, but sometimes our sketches might turn out wobblier than the building itself, which is no harm. And sitting with the building and taking notes and observing it is very important. And it's with thanks to Carl O'Mahony, a friend of mine and an architect here in Ireland, that I really discovered this. He has been working on a castle in County Kerry, I think, and he's been doing an incredible amount of sitting with the building and surveying and observing. And he sent me through a batch of excellent sketches and drawings that he created from those sketches, where his sketch drawings capture some measurements, capture notes, pebbled render, capture window locations, and even details. And there's a close-up of that detail sketch that he did of this ring, this metal ring and hook which he observed. Thank you. And as I said at the start, I'm sorry not to have been with you. My email